All right, today we're taking on graphing rational functions with transformations. So here we go. So first we're graphing the parent function. It's a rational function because we have a fraction and we have a variable in the denominator position. So first we start with our table. So x, y. Okay, I usually go -3 to +3 for this one. So if I plug in a -3, I get a -1/3 as my output. If I plug in a -2, I get -1/2 as my output. If I plug in a -1, I get -1 as my output. If I plug in a 0, 1/0, well, that is undefined. Okay, if I plug in a 1, I get a 1. Plug in a 2, I get 1/2. Plug in a 3, I get 1/3. All right, before I do anything, I want to draw in my two asymptotes. So a rational function will have two asymptotes. I'm going to have an asymptote right here at x = 0. This is a vertical asymptote. So a vertical asymptote at x = 0. So remember, we have a restriction. There is no value here. I can't have a value for x at 0. It would make my entire function undefined. I can never have 0 on the bottom of a fraction. So that graphs here as a vertical asymptote at x = 0. I have another asymptote at y = 0 right here. So this is a horizontal asymptote. So an asymptote is a boundary line that we approach, but we do not cross. So y = 0. So the reason we have that one is because no matter what we plug in for x here, I'm never going to get a value for y at 0. And the reason that is because I have a 1 stuck in the numerator position. The only way to get this fraction to go to 0 is if I could make the top equal to 0. And since I cannot, right, that presents itself as another asymptote. All right, when I plot my points here, I can start with that first point, over 1, up 1. And then as I move over from the origin, as I go over 2, I'm going to go up 1/2. As I go back to the origin and go over 3, I'm going up 1/3. Now we think of the rational function as a reciprocal function. So this point, for example, right here, as I went over 2 and went up 1/2, I could go over 1/2 and up 2 and get another point on my graph. This one right here was right 3, up 1/3. So I could go right 1/3 and up 3 and get another point on my graph. It helps me smooth out my curve when I draw in this branch like so. Okay, so then I need my second branch, which is in this lower left-hand quadrant. So from the origin, over 1, down 1, back to the origin, over 2, down 1/2, 1/2 right there, back to the origin, over 3, down 1/3 right there. And again, because it's a reciprocal function, this point where I went left 2, down 1/2, I could go left 1/2 and down 2, right there. This point, I went left 3, down 1/3, I could go left 1/3 and down 3, just like so. And then again, smooth out my curve, crossing through all of those points. So again, our asymptotes, these are boundary lines that we approach. We hug them, we get super close to them, but we do not cross them. Okay, domain and range. So domain, all the values that x can be. Well, x can be anything, right? All real numbers except can't be 0. So all real numbers, just not 0. Okay, and then my range, well, same thing. Y can be anything except just can't be 0. Okay, if I want to write that in my interval notation, I could say, well, from -∞ to 0, union with 0 to infinity. So we're essentially saying it can be anything, just not 0 itself. Okay, and then over here we're doing the same thing, negative infinity to 0, union with 0 to infinity. So it's implying, right, that one restriction that is at 0 itself. Okay, next one here, I have a negative out in front. So that negative out in front is telling me that this is reflecting. So reflects over the x-axis. Okay, so here I need to first just draw in my asymptotes. That helps me stay centered. Okay, and then it reflects over the x-axis. So that means that that first point that I would have had right here is going to be right here instead. Okay, that next point, over 2 up 1/2, is just going to be down 1/2 instead. Over 3 down 1/3 right there. And then over 1/2 down 2, over 1/3 down 3, and I can smooth it out just like so. So there's that first branch. It got reflected over the x-axis. Okay, the next set would have been right here. That would have been my first point, but I need to reflect it across the x-axis, so it goes right here instead. And then as I move over, it's going to be, here's 1/2, here is 1/3. Okay, and then over 1/2 up 2, over 1/3 up 3, and it's going to look like so. All right, so there is my function. It has been reflected over the x-axis. So here, when I say domain, right, x can be anything, can be all real numbers, just can't be 0. Right? That has not changed. For my range, all real numbers, just y cannot be 0 either. If I write that in my fancy interval notation, I'm saying, well, negative infinity to 0, union, or 0 to infinity, just like that. And the same thing for the range. Negative infinity to 0, union with 0 to infinity. So since I'm not giving a hard bracket to the 0, it's showing that that one value, 0, is the only restricted value for the graph. All other real numbers apply. All right, next one up here for 3. I have 1 over x take away 3. So the fact that I see that minus 3 attached over to the side, that is a vertical translation or shift 3 units down. So if I draw in my asymptotes, 3 units down, it's going to be right here. My asymptote is now at y equals negative 3. Okay, and then here is my vertical asymptote in the same spot. So once I have my asymptotes, I picture where the asymptotes cross as essentially my new makeshift origin, my new starting point. So from here, right, there's no stretch or compression, so I'm going over 1, up 1, over 2, up 1/2, over 3, up 1/3. And if I get those reciprocal points, I have a point here and here as well. So over 1/2, up 2, over 1/3 and up 3, and I can smooth out my curve just like so. Okay, in the opposing region, so again, I'm going back to where I'm centered right here. It's my makeshift origin. Over 1, down 1, over 2, down 1/2, over 3, down 1/3. Okay, my extra points, over 1/2, down 2, over 1/3, and down 3. And here we go. Okay, domain and range. Well, my domain has stayed exactly the same, all real numbers, just not 0. My range, my y values, have changed. So I can see that, well, for my y values, right, if I trace it bottom up, y can be anything. It just can't be negative 3, and then it can be anything else. So here we're going to say all real numbers, y just cannot be -3. So then if I switch to my fancy interval notation, I can say -infinity to 0, union with 0 to infinity, like that. And then my range would be -infinity to -3, union with -3 to infinity, just like so. So again, the interval notation is really just saying, well, hey, here's my restricted value. It's here at -3 instead of 0 for this iteration. All right, next one up. Here I see the x plus 3 on the bottom. So the fact that I see the plus 3 attached to where the x is in the bottom of the fraction, this signals to me that it's a horizontal translation or shift, which is always the opposite of what it appears. So this is 3 units to the left. So that means that my vertical asymptote is going to slide 3 units to the left. So let me draw that in first. Okay, my horizontal asymptote will stay right here at y equals 0. And then I'm just following my parent function from my makeshift origin right here. So I'm going over 1, up 1, back to my makeshift origin, over 2, up 1/2, back to the makeshift origin, over 3, up 1/3, right there. Okay, the reciprocal points, so over 1/2 up 2, over 1/3 and up 3. Okay, connect your dots. There's my first branch, and now my second branch. So from my makeshift origin, over 1, down 1, okay, back to my makeshift origin, over 2, down 1/2, back to my makeshift origin, over 3, down 1/3. Okay, the reciprocal points, over 1/2, down 2, over 1/3, and there we go. Okay, my domain, well, x can be anything. It's just not going to be -3. X cannot be -3. For my range, y can be anything. It just can't be 0. If I write those in my interval notation, here I would say from -infinity to -3, union with -3 to infinity. Okay, over with the range, -infinity to 0, union with 0 to infinity, just like so. All right, last 2. Slide it up. So for problem 5, I see a 3 on top. So that 3 on top is telling me that there is a vertical stretch by a factor of 3. And all that means is that the y values are going to triple. They're going to get multiplied by 3. Okay, let me draw in my asymptotes first, right? There's no horizontal or vertical shift this time. So my asymptotes stay put where they were with the parent. So I have a vertical asymptote at x equals 0. I have a horizontal asymptote at y equals 0. Okay, the stretch of 3. So all of those vertical distances, I am multiplying them by 3. So if I go to the origin, instead of going over 1, up 1, I'm going to multiply that by 3. So I'm going up 3 instead. Next, I would go over 2, and I would go up 1/2. But instead of 1/2, right, I need to triple that. So if I triple that, that would be 3/2. So right here. Okay, and then the last one, over 3, normally I would be going up 1/3, but if I triple that, I'm going up 1. I'm just going to plot using these 3 points. I have enough to smooth out my curve. Okay, for the second set, down in here, okay, back to the origin, normally over 1, down 1, but I have to triple that vertical distance. So if I'm 1 unit away, now I'm 3 units away. Back to the origin. Over 2, normally down 1/2, but I have to triple that. So I'm going to go 3/2, which is 1 and 1/2 right here. Okay, back to the origin. Over 3, usually down 1/3. But if I triple that, I'm going down 1. Those points are plenty. Let's connect the dots and smooth out our curve. All right, so my domain, x can be anything, all real numbers, just not 0. My range, y can be anything, y just cannot be 0. If I write that in my interval notation, I'm saying from -infinity to 0, union with 0 to infinity. That union sign just means or. We're saying it could be this or it could be this. Okay, with the range, same thing, -infinity to 0, union with 0 to infinity, just like so. So we're saying any value works, just not 0. Okay, last one over here. So here I see, down in here, that x minus 4, that tells me that it's undergoing a horizontal translation. So this part, horizontal translation, opposite of what it appears. So horizontal translation, 4 units to the right. Okay, and then right here, the +5 would be a vertical translation, 5 units up. Okay, so we have to move our asymptotes, both of them this time. So 4 to the right, I'm going to have an asymptote right here. There's my new vertical asymptote at x equals 4. Okay, and I'm 5 up, so right here, I have a new horizontal asymptote at y equals 5. Okay, everything else stays the same as the parent function. So from my point of intersection of the asymptotes, my makeshift origin, I'm going over 1 and up 1, back to my makeshift origin, over 2 up 1/2, back to my makeshift origin, over 3 up 1/3. Here I will get those reciprocal points. So over 1/2 and up 2, over 1/3 and up 3, and smooth out the branches like that. Okay, in this region down here, again, I start at that makeshift origin, over 1, down 1, back to that makeshift origin, over 2, down 1/2, back to my makeshift origin, over 3, down 1/3, back to my makeshift origin, over 1/2 and down 2, back to my makeshift origin, over 1/3 and down 3, and boom, we are done. Here we go. So there is my rational function. My domain, what values can x be? Well, x can be anything. We just have a restriction right here at an x value of 4. X cannot be 4. For the range, y could be anything. We just have a restriction right here at a y value of 5. So it can't be 5. And when I write this in interval notation, we're going to say here for the domain, -infinity to 4, union with 4 to infinity. Okay, for the range, I'm going to say -infinity to 5, union with 5 to infinity. Okay, so for all of these rational functions, we start by drawing in our asymptotes. Okay, the only time with our domain and range that we see a change in our restriction, for the parent function, we see that x cannot be 0, y cannot be 0. So the only times that we see that really change is when we see a translation left-right or up-down. For every other iteration, every other variation, we see that the restriction is always at 0. All right, I hope you guys are having a great day. I will see you soon.